Hi everyone, welcome to the course. My name is Pablo Farias and I'll be your instructor. Why is it important to learn JavaScript? Originally designed to make websites interactive, JavaScript quickly became a core building block of the modern web, and is now used in everything, from web development to building games, mobile apps, and even space exploration technology. It's therefore unsurprising that JavaScript is now, according to GitHub, the most popular programming language in the world. The goal of this course is to get you up and running with JavaScript, so that you are familiar with the basics and can go and take on more advanced challenges. Some of the building blocks that we are going to be covering include variables, conditional statements, functions, objects, loops, arrays, and also a basic introduction to the DOM API, which will allow you to connect HTML with JavaScript. No prior experience is required to take this course, although we do recommend that you have some familiarity with HTML. Zenva is an online learning academy with hundreds of thousands of students. We feature a wide range of courses for people who are just starting out or for people who want to learn something new. Our courses are versatile, allowing you to learn in really whatever way you want. You can choose to view the video tutorials, read the lesson summaries, or even follow along with the instructor with the included project files. At Zenva, we don't just love making games, but we also love playing them. That's why we decided to include an optional game narrative you can follow along as part of this course. Want to become a coding mercenary, make money, and solve programming challenges across the galaxy? Continue watching to get started. If you're interested in web development or in building browser-friendly games and apps, learning JavaScript is absolutely essential. It's not only ranked on GitHub as the world's most popular programming language, it's also the most in demand. Of all the companies that are currently hiring developers, 70% are looking for people with JavaScript skills, and the average salary on offer is $114,000 a year. If you are after proof of JavaScript's popularity, just look at some of the world's largest tech companies. It's used by Google, Facebook, Microsoft, and eBay. Netflix used it to drastically speed up their site. Uber uses it to handle real-time data. And NASA and SpaceX have even taken JavaScript to the final frontier. It's clear to see how this easy-to-use, versatile language can open up a world of opportunities. Get started with JavaScript and see where it will take you. You are the leader of a group of aspiring coding mercenaries: pilot, research, and security. Your goal is to travel across the galaxy solving programming challenges and getting paid for it. After years of doing dirty work for the local underworld, you were finally able to save enough money to buy a second-hand spaceship. Your team is really excited and ready to leave this horrible planet. You head into the ship, and inside the ship, you head to the control room to turn the computer on. Unfortunately, you realize that in order to start the ship, you need to be able to run JavaScript code. In this lesson, we're going to look at how to run JavaScript code. For that, we need two things: a web browser and a code editor. When it comes to code editors, there are millions of choices. You can use whichever code editor works for you, but we are going to be covering two of them. One of them is Visual Studio Code, which is free and available for all different operating systems. And for people who don't want to install anything in their computer, we're also going to be looking at rebel.it, which is an online development environment. Up next, we're going to install Visual Studio Code on Windows. On Mac, we are going to run our very first line of JavaScript code. And lastly, we are going to run code on the rebel.it environment. To install Visual Studio Code on Windows, head over to code.visualstudio.com, then click on Download for Windows, which will download the executable file into our computer. Once that completes, we have to execute that file and go over the installation process. I'm just going to go with the default here in terms of where I want this to be located and some of the other options. And when this completes, you should be able to execute Visual Studio right from this installation window or from your start menu. So I'm going to go and launch it from here, and I can see that it is installed. On the Mac, head over to code.visualstudio.com, click on download, select that you want to open it with the archive, you want to extract it in that manner. When the file finishes downloading, you should see the extracted files. From there, drag the Visual Studio Code file to the applications folder if you want it in your taskbar. Otherwise, just double click on it. That should be enough to open the program. So once you've opened it, that means that you are all good to go. We are now ready to execute our very first line of JavaScript code. Now, where are all of our files going to live? It's a good idea at this point to create a folder, maybe in your documents or your desktop or anywhere in your computer that suits you. So I'm going to go and do that here. I'm in Visual Studio Code, and I'm going to go and add a folder into Visual Studio Code. In my case, this is going to be placed in Documents. I'm going to create a new folder here, which is going to be called JS Course, and I'm going to add this folder into Visual Studio. On the left side here, you see the Explorer. If you click there, you'll see that folder that you have, and if you have any files in there, they're going to be showing here. Let's go and create our very first file. I'm going to click on this New File icon. You can also go to File, New File. So let's go and do that. And I'm going to name this file index.html. And in this file here, I want to write my first line of JavaScript code. Now, this is an HTML file. So if I write something here, for example, hello world, and then I go and open this file in my browser. So I'm going to go and find this file in my computer, JS course, and here it is. I'm going to double click on it. So it's going to open in my web browser. You can see that it says hello world. Anything that I write here, normally it will be just shown to the user because that is how HTML works. So we need something different in order to run JavaScript, and that is the script tag. So if I type script, in this case, I'm getting that closing tag automatically added for me. Anything that I add inside of these script tags is going to be interpreted as JavaScript code. So in here, I'm going to write alert, open parentheses, and then quotes, hello world. I'm going to save by pressing Ctrl S or Command S in the Mac. And now I'm going to go and open this file in the browser again. And you can see that we are seeing this pop-up that says hello world. So that means that we are actually executing JavaScript code for the very first time. This is super exciting, and this is where we are going to build everything else from in the following lessons. As mentioned earlier, if you'd rather not install anything in your computer, you can also use web-based code editors. And one of them is REPL.it, which we recommend because it has a pretty good free tier. We have no experience with their paid services, and we are not affiliated with this company. We do like using this in some educational resources such as this. So if you sign up with a free account, you should be able to access your dashboard like so. And then in here, I'm going to go and create a new project, or REPL as they call them. And in our case, that needs to be HTML, CSS, and JavaScript. I'm going to rename this to JavaScript course and create this project. The basic template will look like so. I'm going to go and delete all of these files because we're not really going to use them. And I'm also going to delete all of the contents here. So I'm going to run the same code that I run using Visual Studio. So that is basically adding a script tag. And then inside of the script tag, I'm going to write alert, which will show a prompt for the user on the browser. And in here, it's going to say hello world. And lastly, I'm going to add the closing script tag. That should be it. So if I press the play button now, that is running this code. And I can see that it says here, hello world. It is important to mention that if you are serious about programming, we actually recommend using Visual Studio Code or any code editor that is based in your computer, because cloud editors can be great for learning and to get something up and running really quickly. But once you're starting to develop real projects, you are probably want to move to a computer-based environment. Well, that is all for this lesson. I'm super excited that we can now run code, and in the next few lessons we're going to be exploring how to include JavaScript files and also all of the basic programming fundamentals. So don't worry if you're confused by me using parentheses or quotes or any of that stuff. Everything is going to make complete sense once we go over the basics. So I'm super excited to continue and looking forward to see everyone in the next lesson. After a bit of research, your team figured out how to run JavaScript code in your ship's computer. Now that the ship's on, you're being prompted to create a user account for the pilot of the ship. So we're going to be entering pilot's details here. We need to enter her name, whether she has experience or not, her age, and lastly, the score she obtained in the flying exam. For all of these, we're going to be using variables, a really important construct that is common to most programming languages. Think of variables as a way to store and retrieve data from the memory of your computer. A variable has a name and a value. The data stored in a variable can be of a certain data type. For example, if we are saving somebody's name, that is probably going to be text. If we're saving somebody's age, that's going to be a number. If we are saving whether they are a zombie or not, that might be a true or false value. We are going to go over all of the main ones once we start coding. It's important to mention that JavaScript as a language is dynamically typed. That means when you declare a variable, you don't need to specify what type of data will be stored in that variable. A lot of this might sound a little bit abstract at the moment, so let's jump over to our code editor and get started with some working examples. In Visual Studio Code, and in order to keep things organized, I've gone ahead and created a subfolder with the code of the previous lesson. So that's the code of the previous lesson. And I'm going to go here and create a new subfolder for the code of this lesson. So I'm going to call this subfolder o2-variables. And inside of this variables folder, I'm going to go and create a new HTML file. And this is where we are going to be working in this lesson. I'm going to start by adding the script tags. And it is in between the script tags that all of our code will go. One of the advantages of JavaScript is that you can run it directly in the browser. And I like to keep the browser visible at all times so that I can make changes in the code and then I can refresh the page in the browser and see if there are any errors or any console messages I need to pay attention to. So what I'm going to do is open this newly created file, and I'm going to open it. In this case, I'm going to be using Google Chrome, but you can use any modern web browser to follow along with this course. I'm just going to make sure that both the code and the browser are visible. And in the code editor, I am going to hide the sidebar by pressing Ctrl B or Command B in the Mac. And here we go. In the browser itself, I'm going to right click and click on Inspect, which brings up the developer options here. And I'm going to click on Console. That's what we're going to be using here, so that whenever we create variables or if there are any errors, they are going to be shown here in the console. Now let's go and create our first variable. When you create a variable, that's called a variable declaration. To declare a variable, we're going to be using the let keyword. Now we need to give our variable a name, and I'm going to call it age. Lastly, to close this statement, we're going to be using the semicolon. Semicolons are not compulsory in JavaScript. However, it's highly recommended you do use them because they can actually sort out some ambiguities that can happen if you don't use them. So it's better if you use them from the get-go. So we've declared a variable here, but it doesn't have any value. Let's go over variable assignment. So I'm going to start by typing the name of the variable, age, the equal sign, and in this case, this is going to be a number, and I'm going to use the semicolon again to close this statement. And we want to show this in the console. For that, we need to type console.log parentheses, and inside the parentheses, we add the name of the variable that we want to show, and finish that with the semicolon as well. So I'm going to save, And now I'm going to refresh the browser here. And you can see that the console of the browser is showing the number 50. Now, you can also do the declaration and assignment in the same line. Let's do that with a different variable. Let's go and create a variable called name, declaration, and assignment. So let's call this variable name, and then we'll use the equal sign and give this variable a value. The value here is going to be text, so that goes between either single quotes or double quotes. This is going to be called pilot, semicolon. This is known as a string. It's a data type that is used to store text. So we've looked, this is a number. As you can see, there were no quotes, and this is a string. So this is a piece of text. We can go and do console.log, name, semicolon, save. Always save before you're going to refresh the browser. Refresh the browser. And you can see now that we are also seeing the pilot value. Great, so what else can we do here? We can create another variable to store whether the current pilot has experience flying an airship or not. So this is going to be a Boolean variable, which can be true or false. So let's use the let keyword again, and let's give this variable a name, has experience, equal sign, and true, or it could be false as well. And see how we are also not using the quotes for Boolean variables. Console.log, has experience, semicolon, save, and now refresh the browser, and you get the value here. I also want to show you that, well, this can be used to represent integers. You can also represent floating point numbers, or numbers that have decimals in JavaScript. So we're going to use that. This is another number basically, and this is going to be the exam result. So somebody did an exam, and how did they go? Let's say they obtained 50.5. So to create variables that have a decimal point, just simply use the dot, which is commonly used in many countries. However, some other countries use the comma, but in programming, you always use the dot to represent that. And you can see that that is correctly shown here. Now, what happens if I create a variable and I don't give it any value and then I show it in the console? Well, let's see and try. Let's try that. So I'm not going to give you the answer right away. Let's go and create a variable called something, and let's go and show it in the console. Let's go and see what happens. And we get this undefined value. So that is an important thing to have in mind in JavaScript, is that if you don't give a variable a value, its value will be of undefined. Now, you can, in this same way, you can also make changes to the value of a variable. For example, let's say I want to change the value of this exam. So I can type exam results and see how Visual Studio Code already starts completing these. So if I click on that, it will just complete it for me. Let's say that I give it now a value of 100, and I will show this again. And there we go. So you can do this with assignment. You can reassign the value of a variable. You can even do, because this is dynamically typed, it means that a variable, even though it had a number, we can actually give it anything else, any other data type, for example, some text, and it will actually work. However, it is not recommended that you do this. Just for clarity purposes, you usually want to stick with the same data type. Something that you are not allowed to do is to redeclare the variable using the let keyword. So if I go here and I type let exam result again, and I don't even have to try to assign anything. I can if I want to, but I don't have to. And if you go and run this code, you're going to see an error. And when you see an error like this, you will usually see in what line the error is present. In this case, it says 30. So if I go here and that is line 30, you can see how that is the conflicting code. So we are going to delete that. Well, that is the basics of variables. As you can see, it's super easy to create variables, to change their values, And this is one of the building blocks of programming. I'm really looking forward to seeing what else you will achieve in the following lessons as we go over some of the other basic constructs of the JavaScript language. I will see you then. Exploring the galaxy and searching for coding contracts will take a lot of time. It would be good to buy as much fuel as we can for this journey. Now, how much can we carry with us? Well, the spaceship only has a limited carrying capacity, and we need to be able to know whether we can carry everything. So we need to calculate the weight of the ship, the fuel that we are carrying, the food, and also the passengers. For all of these, we're going to need the help of the computer. And in particular, we're going to be using arithmetic operators. Luckily for us, computers are really good at math. In fact, that was one of the reasons why computers were invented in the first place. In this lesson, we're going to be going over some of the main operators in JavaScript, including addition, subtraction, multiplication, division, and the modulus operator or division reminder. Let's head over to our code editor and get started with some examples. I'm going to start by creating a new folder for this lesson, which I'm going to call Arithmetic Operators. Inside of this folder, I'm going to add a file named index.html, and inside of that file, I'm going to open my script tags. Now, in previous lessons, we've added all of our JavaScript code in between the script tags. In this lesson, we're going to take a different approach. We're going to use an external JavaScript file. So I'm going to go and add an additional file to my folder, which is going to be called script.js. The JS extension is what identifies JavaScript files. In index.html, we're going to keep the script tag, but instead of adding our code in between the script tags, we're going to add an attribute here called source or src, and we're going to give it the value of the name of the file. You can see how I'm already seeing this auto-completion here. So I'm just going to click on that. This means that we are going to basically execute all of the code that is in script.js. Next, we need to open index.html in our browser. So I'm going to find the file and open it, in my case, on Google Chrome. And I'm going to right click and then click on inspect to get the developer console shown. And in here, I'm going to click on script.js, and we can start with the first of the arithmetic operations that we're going to be looking at. Addition is simply adding numbers using the plus sign. I'm going to type 2 forward slashes, which means a comment is coming. Whenever you type 2 forward slashes like so, that means that anything you write after that is for the person reading the code. It is not executed by JavaScript. So I am adding that comment there. And addition, as I mentioned, is simply adding numbers with the plus sign. So I'm going to go and create a variable here called a, and this is going to be simply 1 plus 1. We're going to show that on the console and save and then run this. And as you can see, we get, as expected, that number 2 as a result. You can also add multiple variables. So I could create a second variable called b, which will have a value of 10. And I could create a third variable called c, and we can do a plus b. And the result from that should be 2 plus 10, so 12. Let's save and reload here. And there we go. Now, what if I want to increase b? Let's say that I want to increase b by 1. So I want it to be 11 instead of 10. Well, I can always do an assignment. So I can do b equals. It's going to equal the previous value of b, that means 10, plus 1. So the result here should be 11. This is also equivalent to doing the following. Instead of typing b equals b plus 1, you can just type b plus equals 1. This is exactly the same. In programming, it's quite common to find ways to do things in a more efficient manner. So this is just a shortcut for this here. If we save and reload the page, you're going to see that nothing has changed. Next on the list, we have subtraction, which works very similarly to addition. Let me create a variable here, x equals 10, and this can be 10 minus 5, for example. That should give you 5 as a result. Let's show it in the console and reload, and you got 5 as a result. And you can combine both addition and subtraction just like you would do in plain regular algebra outside of computer science. Sorry, arithmetic. So you could have y equals, let's say, b plus x. So that's my b from here, which was 11 plus 5, so it should be 16. Console.log y, and if we reload there, we got 16. Similarly, if we wanted to decrease the value of a variable, we could do, if we wanted to reduce the number of x, for example, we could do x equals x minus 1. And that is also the same as doing x minus equal 1. So it is exactly the same thing. Console.log x 4 instead of 5. So it was 5 before, now it's 4. And this is identical. So instead of you doing the plus here, like we did before, we use a minus sign. Multiplication, let's call this unit price. Let's say this is the price of 1 unit of food, for example. So each unit of food is priced at $2, and you have a total of 10 units. So what is it going to be? What is the price going to be of the total? The total is going to be the unit price times the number of units. So you can do that by multiplying unit price, and see how as I start typing, I get all of these suggestions. If I press enter, I can just go with the suggestion that is being selected. So I'm going to use the multiplication sign, units. So the total price should be the price per unit times the number of units. And I can show this in the console. Console.log total. And let's see if that is correct. 20. Did we expect this to be 20? That would be 2 times 10. Yeah, that is certainly 20. So that is good. Then we have division, which also works in a way that is intuitive from arithmetic, from primary school or middle school. So if we have, let's say that we have a number n equals 10 and we want to divide 10 by 2, we can do result equals n divided by 2. So this is the sign that we use for division, a single forward slash. Remember that 2 forward slashes will turn this into a comment. So we definitely just want to use 1. Lastly, we have the modulus operator, which is the division reminder. Imagine that you have 5 cakes and 2 children, and you want to divide that so that each children ends up getting, let's say, 2 cakes, and then you have 1 spare cake, 1 extra cake. So that would be the reminder. So in that particular case, you can say, let's call this R. Let's say 5, the remainder of 5 divided by 2 should be 1. So if you have 5 cakes, 2 children, each children is going to get 2 cakes, and you're going to have 1 spare cake. So let's show this in the console. This is not as commonly used as the other 4 operators, but it is certainly important to know. So here we go, 1. We are going to end this lesson with a challenge. We need to calculate the total weight of the ship. We know the following. We know that the aircraft itself weighs this much. We know that we are carrying this much of food, this much of passengers, and also we know the weight of 1 unit of fuel, and we know how many units of fuel we need to put in our ship. So we need to get that total weight. I'm going to pause the video now. You can have a go, and then you'll see the solution. So pause your video now. All right, well, thanks for trying. Let's go and have a go at solving this challenge. So the total weight of the ship, I'm going to call this total weight, is going to be equal to the base weight plus the food weight plus the passengers weight. And see how I'm using the auto completion of Visual Studio. I'm just pressing enter and getting all of that auto completed for me. And lastly, we also need to add the fuel. But before adding the fuel, I'm actually going to save that fuel in a separate variable just to keep things a little bit cleaner here. So we're going to calculate the fuel weight, and that fuel weight is what's going to go here at the end. Now let's go and calculate this. If we know that that 1 unit of fuel is 2, and we know that we have 100 units, then all we need to do is multiply these 2 numbers, because that will give us the total weight that we are carrying. and that is the calculation. So if we show this in the console, total weight, and we got the total there of 310. Well, that is all for this lesson. Thanks for watching. I'm really looking forward to seeing you in the next lesson. Shortly after leaving your home planet, your ship entered an asteroid belt. It's important to be really careful here. It's easy to collide with some of these giant rocks. You need to enter the right information in the ship's computer so that it can make the best decision for you. If you go left, you're going to end up in the red planet. If you go right, you're going to end up in the purple planet. You can always go back, but if you go into any other direction, the ship's going to crash. For this, we're going to be using conditional statements, which will tell us what will happen in each one of these scenarios. Conditional statements are a really important programming construct present in most languages, and it is quite easy to grasp, as it basically means that you can have different executions, different paths of execution based on a certain condition. For example, if somebody obtains more than, say, 50 in their exam, that means that they passed the exam. If they obtain less than 50, they fail the exam. So you set a condition, and then different things can happen if that condition is true or false. In particular, we're going to talk about if statements, else if statements, and else statements. Let's head over to our code editor and start working in some examples. I've created a new folder for this lesson, as I'll be doing in all lessons going forward, as well as an empty script.js file and index.html, which all it does is include the JavaScript file. I've also opened index.html in my web browser of choice, and I've got that here. So I'm going to go into script.js and start working on the first conditional statement. I'm going to start by creating a variable which will store the direction that our ship is moving towards. So let's type in let, and let's call this variable direction. And to start with, I'm just going to give it an empty string as a value, basically a text, but there's no text in it just yet. So it's an empty string. We're going to create an if statement which will evaluate whether that direction is equal to left. And if that is the case, we're going to head over to the red planet. So I'm going to type if, and then parentheses. Inside of the parentheses, we need to add the condition that we're going to evaluate. The condition will be direction is equal to left. So a couple of things here. See how left is just a string. It's text. And I'm using two equal signs instead of one equal sign. This is because we are comparing. This is a comparison operator. It's not an assignment. We're not changing the value of direction. We're simply checking whether direction is equal to left. If that is true, then we're going to execute whatever code goes inside of the if statement. I'm going to open a curly brackets, and as you see, the closing bracket has been created for me by Visual Studio Code. I'm going to press enter here, and if the condition is true, we're going to show in the console where it is that we are going, which is going to be the red planet. Let's go and execute this code to see what we get, if we get anything. So we don't see anything here, and that is because this condition is currently false. Therefore, what's inside here is not being executed. What if I go and change this direction to left and try this again? You can see now that we get this red planet prompt in the console. So we're basically checking this, and if this is true, we are executing this code that's inside. Now, what if we want to check for a different condition? What happens if you go right? Then you should end up in the purple planet. For that, we have different options. So one option would be to basically do this again, to do this same code again, but just change this to right and to go purple planet. But imagine that this value is left, So we check this condition, this is true. It's not really necessary to check the other one. We already know that that's not going to be the case. That's why we use else if. In this manner, the second condition is only checked if the first condition was false. Let's go and run this. So we get the same because we're still going left, but what if I change this to right? Now we're going to the purple planet. And you can add as many of these as you want. For example, if I go copy and paste this block and add backwards, then I can type that we are going back home. So if you decide to go backwards, you're going to be sent back home. Now, there was another condition that we talked about, which was if you go to any other direction, you're going to crash. For that, we can make use of an else statement. An else statement will catch anything that was not caught by these previous conditions. Please note that you don't need to have else if in order to have else. All you need is just an if, so you can have just if and then else, and that is enough. So any other direction here should mean that the ship crashes. So what if now I say, let's go, I don't know, diagonal? You're going to see that the ship crashes. So that is really the basic of conditional statements. We define a condition, and that condition can be either true or false, and if it is true, then this code is executed, and none of the other ones are executed, so none of this is executed. Well, with that in mind, you already have a really powerful tool in your hand. You can create computer programs that check the value of certain values, certain variables, and according to those values, carry out different actions. That is already a big leap in terms of what you can do with these programs. Thank you for watching. I'm really looking forward to seeing you in the next lesson. After surviving a very dangerous asteroid belt, your ship reaches the red planet. The orbiting space station is a well-established shop. However, they are having software issues, and the owner tells you they are willing to pay you if you code something for them. Well, it seems you found your very first coding contract. Let's look at the specifics. The customer that comes into the shop will have a balance of credits, and if they want to buy something, you need to check the cost of the item. If they can buy it, then you need to update their balance. And if they cannot buy it, you need to let them know that they don't have enough money. We're going to be using comparison operators for this. Comparison operators allow us to compare variables in various ways, and when used in combination with if and else statements, they allow for really rich and complex logic. We can do basically everything we want when it comes to comparing numbers and comparing quantities and making decisions in our programs based on that. Let's head over to our code editor and build this shop. In Visual Studio, I've created a new folder, an empty script.js file, an index.html file that all it does, it loads the JavaScript file with script tags, and I've also opened the HTML file in the browser. So we're going to go and open script.js, and the first comparison operator we're going to talk about is the one we've already seen, which is the equal operator. So let's go and declare a variable here called item, and this is going to be called have the value of engine. And let's say that you want to check whether the item is an engine. So we're going to use the two equal signs as we did in the previous lesson, and we're going to check whether this is an engine. Console.log engine. Let's go and run this code, and as expected, it shows engine. Now, what if you want to check whether the item is not an engine? Well, what you can do is use the not equal operator, which starts with an exclamation mark and then it has the equal sign. This means it's not equal. And in this case, it would be not an engine. if we run this code again, you're going to see that nothing happens because this is no longer true, as item is indeed equal to engine, and this requires us to have something that is not an engine. So what if instead of engine, then I say, I don't know, this is a window? You're going to see that this is now true because window is not equal to engine. So there you have equality and also inequality. We can also compare numbers, and that is quite useful. Let's say that you have a score of 50 and you need somebody to have a score of, let's say, over 50 in order to pass. So you can check if score is greater than 60, the person will pass. And if that is not the case, so else console.log not pass. So let's run this code and see what we get. We get not pass because 50 is not greater than 60. What if this was 60? 60 is also not greater than 60. Let's go and check that out. If you want this to be greater than or equal than a certain number, then you need to add the equal sign, like so. Just like you can check whether some value is greater than another value, you can also do the opposite, compare that it is less than, by using this sign instead. So for example, you could have another condition here which says that if the score is actually less than 10, it did quite poor, so maybe they have to, I don't know, meet the teacher. So let's set the score to, let's say, 5, and you're going to see that they need to go and meet the teacher. As you can see, also we're not executing the not pass condition here because only one of them is executed, the first one that is true. So this one's false, so this is not executed. Then this one's true, so this is executed, and that's the end of it. Then we move on past the whole conditional statement. There's something else that I want to show you when it comes to comparison operators, and it's that you can store the result of a condition in a variable. You can have, in JavaScript, you can have variables that are Boolean. So let's go and create a variable, for example, and you can name them whatever you want, but I usually like to name them starting with is or has, so that I know in advance that it's probably going to be true or false. For example, you could have a variable that stores whether something is an engine or not. So you could call it isEngine, and this could be our item and whether it is equal to engine. Console.log isEngine. Let's run that, and we get false as a result. We get false because item is actually window, and window is not equal to engine, so the result of this condition is false, and we're storing that in a variable. You could add this in an if statement if you wanted, so you could have just the variable there, and you could have something happening if that is an engine, like so. Instead of having the conditions there, you can save them in variables. We are going to end this lesson with a challenge. Let's say that we have the customer's balance and we have the price of an item. So we need to check whether the customer can or cannot afford this item. And if they can afford it, if they have enough credits, then we need to update their balance. And in either case, we want to show a message in the console saying that the item has been purchased and this is the new balance, or the item could not be purchased because there was not enough balance. Go ahead and pause the video, and afterwards I will show you the solution. Well, great. Hope you had a good time trying to solve this challenge. Let's go and implement a solution ourselves. So the first thing I want to do is check whether the customer has balance. So I'm going to use an if statement, and I'm going to check that balance is greater than or equal than the item price. This basically means that I need the price to be less than the balance, otherwise I cannot afford it. So if that is the case, then we are going to update the balance. I'm going to type a comment here, update balance. So the new balance is going to be the old balance minus the item price. And this is actually exactly the same as writing balance minus equal item price. And that is mainly because programmers are a little bit lazy, so there are always more like efficient or shorter ways to do something. So if you've done it like so, that is perfectly fine. I just wanted to show you that this is also just as valid. Like we said, we have to notify the user of this transaction. So item purchased, and I'm also going to show the user's balance, like so, balance. That's going to be the new balance. And if there was not enough balance to buy the item, we're going to let the user know. So let's go and run this. And in this case, the item was purchased. The new balance is 90. And if the item was a lot more expensive, the outcome would have been different. So let's go and run that. It would have said not enough balance. Great. Well, with comparison operators plus conditional statements plus basic arithmetic, there are really no limits to what you can do at this point. These are all foundational concepts in programming, in all programming languages. So it is really great that you've gotten this far. And I'm really looking forward to seeing what you'll get up to once we cover some more of these programming constructs. I'm looking forward to seeing you in the next lesson. Thank you for watching, and I will see you soon. Space can be a dangerous place. A small rock hit your ship, and now you're losing speed and fast. Luckily, there's a planet nearby, and you might be able to make it. That will depend on a few conditions. If the distance between you and the planet is greater than 200, you're not gonna make it. If that distance is between 200 and 100, you're gonna need at least 100 units of fuel to make it to the planet. If the distance is less than 100, you're gonna need at least 25 of fuel. And there's another condition as well. If the engine is damaged, you are not gonna make it, regardless of any other condition. How can we represent this scenario in the computer? Well, for that, we're going to be using Boolean logic. We're going to go over Boolean variables. These are variables that can have true or false values. And we're going to go over some Boolean operators. In particular, the AND operator, the OR operator, and NOT, which is when you are negating an expression. I've created a new folder for this lesson, as well as an empty JavaScript file and an index.html file that all it does, it loads the JavaScript file. I've also loaded the index.html file in my browser. We're going to start with the first of these conditions. If the distance is greater than 200, the ship is not going to make it. Let's create a variable for our distance and give it a value of, let's say, 250. To represent this condition, we're going to use an if statement. So if the distance is greater than 200, then we are not going to make it. So we're going to show that to the user. So that is pretty straightforward. And as expected, we are getting that result here. What about the next condition? That one's a little bit more complex. So we have distance between 100 and 200. And also we have this requirement of having at least 100 fuel. Let's look at the first part. So we're going to add an else if statement, because we only want to check that condition if this one was false. For starters, we need the distance to be less than or equal than 200. But then also we need the distance to be greater than or equal than 100. How do we link these two conditions? Well, that's where the AND operator comes into play, which is represented like so. This basically means this is all one statement now. And for that statement to be true, you need all of the individual statements to be true. So that needs to be true, that needs to be true. If they're both true, then this whole condition is true. That is what the AND operator does. You can have more than two as well. So now we also need to add another one for the fuel. Let's create a variable for our fuel. Let's give it a value of 100. And I can add another condition here, so another AND operator. And I can say that fuel needs to be greater than or equal than 100. And if that is the case, then we're going to show in the console that you will make it. With the AND operator, all you need is a single one of these to be false, and then the whole statement is going to be false. Also, as you can see, this is getting a little bit hard to read. We can't even fit it here in the screen. So we can make use of a Boolean variable to store, for example, the distance condition. In order to do that, we can just add it here. Let's call this distance condition. And we can go and cut all of this and paste it here so that this variable will store the result of this statement. That will be a true or false value. That is what Boolean variables are. You can always check this in the console and see it for yourself. So we're going to add that condition here. So we need this to be true, and also we need at least 100 of fuel. So this makes the code a little bit more readable. Save, refresh the browser. You can see that the condition is false because the distance is 250, and because of that we're not going to make it. And if we go and change this number to, let's say, 150 and try again, you're going to see that now the condition is true and that you will indeed make it to the planet. With that said, I'm going to leave you the third condition here as a challenge. I will pause the video and then I will show you the solution. All right, welcome back. Let's implement that third condition then. So this will be another else if, and we need distance to be less than 100, and we need fuel to be greater than or equal than 25. So if that's the case, we will make it. Copy and paste there. Cool. Now we're going to look at the last one of these conditions, which is that the engine, if the engine is damaged, you are not going to make it regardless of any other condition. That means that if the engine is broken, it's not going to matter how far we are from the planet. For that, we can also use a Boolean variable. I'm going to delete this console log statement here. And this is going to call is engine broken. So if the engine is broken, this is going to be true. And if the engine is not broken, this is going to be false. Let's set it to false. Let's set it to true first, because we need this. We need this to happen. We're not going to make it regardless of any other condition if the engine is broken. And there are many ways of doing this, by the way. Just because it is a condition that overrules all of the other ones, I would probably add it at the start so that if it is true, then we just don't bother checking anything else. So I'm going to go and I'm going to keep this as a separate condition, else if, and I'm going to add the if here at the beginning. If the engine is broken, then we are not going to make it. If you wanted to write this in a different manner, you could do it like so. You could have instead of is engine broken, you could say is engine functioning. So it's not broken basically. And then instead of checking whether the engine is broken, you could check that the engine is not functioning. So that would be the not operator. And the not operator uses an exclamation mark like so. So if this is true, then this is going to be false. And if this is false, then this is going to be true, because the exclamation mark, all it does, it changes from true to false. The last operator I want to show you is the OR operator. The OR operator is a bit different to the AND operator in the sense that the AND operator requires every condition to be true. But with the OR operator, all you need is one of them to be true, or all of them to be true, but you need at least one to be true for the whole statement to be true. And where are we going to include that here? Well, let's go. Let's combine these two into one. In either of these two cases, you're not going to make it, right? If the engine is broken, you're not going to make it. Or if the distance is greater than 200, you're also not going to make it. So this is a good candidate. And what I'm going to do is cut this here and combine them in one single statement here. And the OR operator is written like so. So two vertical lines. We're going to delete that. And this means that if the engine is not functioning, right, with the exclamation mark, or the distance is greater than 200, we only need one of those two things to happen, we are not going to make it. Let's refresh here to see what happens, so you can see that we are not going to make it. Because this is, the engine is not functioning, therefore this is true, because we're using negation, exclamation mark, and that's all we need. Distance-wise, we're fine. 150 is fine. but all we needed was just one of these to be true for this whole expression to be true. And we can try the other way around. So we could say that the engine is indeed functioning, but our distance is 250, and we should be getting the exact same result, as you can see. Well, that is all for this lesson. I hope you've enjoyed this video, and I'm really looking forward to seeing you in the next one for more exciting programming fundamental concepts. Orbiting around the giant planet, you find an abandoned robotic station, which you claim to yourself. While not your usual mercenary contract, it would be quite lucrative to program this station and turn it into a space shop. Now, how would this store work? Orders would come in. We would need to check whether we have enough stock to sell the item. If we do, we would reduce the stock and we would increase the account balance when payment is received. It is important to mention that this needs to be repeated multiple times, so we might have multiple orders coming in and we need to be able to handle that. For this, we're going to be using functions. Functions are a very important programming concept that is present in many programming languages as well as mathematics. There are many definitions to functions, but think of them as procedures that can be executed multiple times. Just like with a factory, a function can have some inputs and also an output. You can have multiple inputs. In JavaScript, you can also have no inputs and you can also have no outputs. But if there will be an output, it is only a single value that is returned. In this lesson, we're going to be covering functions, in particular, how to declare functions and execute them, parameters, and also function expressions. Let's head over to our code editor and get started. When introducing a new concept, it really helps to start with the most simple example that you can think of. Our first function is going to be a hour to minutes converter. So we know that 1 hour is 60 minutes. To declare a function, use the function keyword. Next, we're going to give our function a name. This will be hour to minutes. When declaring functions, you then have to use the parentheses. And if you will be taking in any input, any parameters, you need to add them here. In this case, we just need one parameter, which is the number of hours. If you need more parameters, you can use a comma and give them other names, like so. Next, we need to declare the body of the function. This is the code that will be executed. And for that, we use the curly brackets. And in here, we can add any number of lines of code, of statements and instructions, as many as we want. I'm going to start by creating a variable in here, which will store the result of the calculation. The calculation will be hours times 60. That is the number of minutes. Lastly, I want to be able to pass on this result outside of the function so that it can be stored in a variable somewhere else. For that, I'm going to use the return statement and type in the name of the variable. When the code of a function is executed, as soon as you reach the return statement, the execution ends. Then you're pretty much quitting the function. So this is the declaration of a function. But this is the equivalent of having a cooking recipe. If you have the recipe for a cake, it is just a piece of paper with instructions. You don't really have a cake until you execute that recipe. So we don't really know anything about minutes until we actually execute this function. Let's go and store some results and see if this works for us. So I'm going to declare a variable here called a, and we're going to execute our function, hour to minutes. And let's say how many minutes are there in 10 hours. We can show that in the console if we want. And you can see that 10 hours have 600 minutes. And you can do this as many times as you want. For example, you could call this again in a different variable and pass in a different number and also show that in the console. If you want to be showing this in the console each time, you could also add it here. So functions don't only return things, they can also do things. Sorry, this should be result. There we go. So functions can actually do different things. And as you can see, we have both results here in the console as expected. Great, well, that is a basic function declaration. Something else we can do is create what's called a function expression, which is when you declare a function and put it inside of a variable, and then you can execute that in the same way. Functions in JavaScript are just another data type. So just like you can have variables that are numbers, that are strings or text, booleans, that's true or false, you can also have functions that are, variables that are just a function. So let's go and create one of those. Let's create a variable which is going to be called day to hours. Basically, how many hours are there in a day? And we can give this a value, and the value will be a function. And that function, you don't actually have to give it a name. It can be what's called anonymous. Then you just add the parentheses, and you can add your parameter here. Let's say this is going to convert from days to hours. So we're going to pass in the number of days, create the body of our function, and in here, we're going to do something similar to what we did before. But I'm also going to show you how you can do it all in a single line of code, like so, days times 24. So if I pass in 1 day, I get 24 hours, that result there. If I want to execute this, let's put it in another function here, day to hours. I can pass in 1 day and show the result in the console. And here we go, 24 hours. So this is a function expression. And in a function expression, it's common to add the semicolon at the end because you're declaring a variable. When you declare a function like so, you can if you want, but it's not common to add a semicolon. Well, these are the basics. And now we're going to look at our shop representation, which was like so. The customer will buy something. We're going to check whether there is enough stock, and we're going to reduce the stock and increase the account balance. We're going to start by declaring a few variables. We are going to be storing the balance as a variable. Let's say that the shop has 100 credits or $100. The number of stock. Let's say that we have 50 items. The price of one item, let's say that it is $5. And lastly, the quantity of the order. Let's say that they are trying to purchase 8 items. And the approach here will be firstly to check if we have stock. And secondly, if we do have stock, reduce the stock after the sale and increase the balance. I'm going to leave this as an optional challenge. It's perfectly fine if you'd rather keep watching and seeing the solution. So if you want, pause the video, see if you can implement these with what we've seen so far, and also see if you can implement it in a function. It's perfectly fine if you'd rather watch the solution. Great. Well, let's go and start implementing this. So first, we want to check the balance. We want to check the stock. So we want to make sure that the quantity of items that the customer wants to buy is less than or equal than our stock. And if that is the case, we're going to reduce the stock and we're going to increase the balance. So to reduce the stock, new stock will be equal to the old stock minus the quantity that's being purchased. This is equivalent to saying stock minus equal quantity. Next, the balance increase. Balance is equal to the old balance plus the price per item times the quantity of items. If I bought 1 item, then I'm only making $5. If I bought 10 items, I'm making $50. And this is also equivalent to writing it like so. Balance plus equal price times quantity. Great. Well, we do want to keep the user informed, so I'm going to add some console logs here. And this is the purchase completed. And you can add the balance as well, or the quantity. So I can add a comma here and add more information for the user. So let's show the new balance and let's show the new stock. And if the sale did not go through, I'm also going to let the user know. Console.log. So let's go and try this out first. So we can see that we just completed a purchase. Our balance increased by 40, which is the amount we would have expected, 5 times 8. And the stock is now 42 after taking 8. So if you wanted to do this for let's say a new order comes in, I would have to copy everything and paste everything and change what the new order is going to be. Run this again, and you can see that everything's being updated. And if I want to do it again, I would have to keep on copying this. You can see how this would quickly become very hard to manage. Imagine you have an error somewhere in this calculation, and if you're doing this 10 times, you're going to have to find that error 10 times and fix it. It is much better if we use functions. I'm going to delete this second operation here, and I am also going to delete this quantity variable, and I'm going to put all of this inside of a function. So function, let's call this sell item. The parameter here is going to be the quantity, and I'm going to open the curly brackets for the body of the function, and I'm going to close them at the end because everything needs to be contained inside of my curly brackets. And you can see that I've selected everything. Now I'm going to press Tab, which is going to indent it just for better readability. And now that I have this function here, I can execute it as many times as I want with different numbers, and you're going to see how the balance is going to be updated each time. So let's go and run this. See how we basically used up all the stock until there's no more stock. Well, those are the basics of functions. A really useful concept because now you don't have to repeat yourself anymore. You can just write your code once and then run it many times using functions. Thank you for watching. I will see you in the next lesson. After repairing your ship, money is running a little bit low. It might be good to branch out into other areas. Your team member, research, thinks making video games could be a good use of your time, especially while you're traveling between star systems. When making games, you'll need to represent the player in your code. This can include attributes such as the player's name, the score, the health, whether they are active users, and in some games the outfit, in particular the outfit's color, size, cost, and whether it's new or second-hand. In JavaScript, you can certainly use variables to store all of this information. You would end up with 8 different variables. However, since all of these attributes belong to the same entity, in this case the player, we could also create an object which will contain all of this information about the player. Objects are data structures that allow you to store multiple properties and more complex entities in a single variable. Think of an object as a collection of properties that have a name and a value. In this lesson, we're going to go over how to declare objects, how to access these properties, how to modify the values of the properties, and also we're going to look at nested objects, which is when you have objects that contain other objects as properties. Let's head over to our code editor and get started. Let's go and create the variable for our player. So I'm going to type let player and give this variable an empty object to start with. To create an object, simply use the curly brackets. I'm going to add the semicolon at the end as well. Let's show this in the console. What we're seeing in the console here is simply an empty object. An object that doesn't have any properties. If you expand on this by clicking on the arrow, you're going to see that there are no custom properties, except the only one that is shown is a default one that we're not going to be looking at. To create properties, simply go inside of the curly brackets and add the name of your property. In this case, let's call this property age. Then add a colon. You can add a space if you want, and we're going to give this a value, 99. Let's save and look at what we get in the browser. You can see that it's showing the property that we declared, and if we expand on this, we're also going to see it here. To add more properties, simply use a comma to separate them. So I'm going to add the name as well. This is going to be a string. Let's call this ABC and see what we get now. So you can see that there are 2 properties here, age and name. And if you click on it, you're going to see them listed. It is common for readability purposes to add new lines in between the curly brackets and the properties, and then to separate each property into a new line, like so. This is just going to make the code more readable. And we can go and add a few more properties if we want to. For example, whether they're active or not. I'm going to call this isActive. And this is going to be a Boolean variable. I'm going to give it a value of true. And we can show that in the console as well. And we have 3 properties now. To access any of these properties, after you've declared the object, let's do that here. Let's show one of them in the console. You can simply type the name of the variable, player, and then dot and the name of the property. And you're going to see that Visual Studio Code already shows you the properties that are available. So in this case, we can show the name of the player in the console if we want by doing that. That would be the name of the player. Another way of doing this exact same thing is, instead of using the dot notation, we can use square brackets and then quotes and the name of the property, in this case name, and this is going to give you exactly the same result. In JavaScript, it's common to have multiple ways of doing the same thing, so I'm just showing you two alternatives here. I personally tend to use this one. When it comes to modifying a property, you follow the same approach. Let's say that we want to make this player inactive. I can type player.isActive, and then I can give it a different value, which will be false. And I can show the object in the console again, and you should see now that the player is now set to inactive. You can also add new properties after the object has been declared. I can give the player a health property, for example, like that, and then give it a number. And I can show this in the console again. And you're going to see that I just added a new property. For the sake of completeness, I'm also going to show you how to delete a property, although I do have to say that this is going a little bit in the danger zone, because if you delete a property and then you try to access it, you might run into some errors. So let's delete the property like that with the delete keyword, and you're going to see that that property is now gone. Great, so that is how you work with a simple object, and what I'm going to show you now is just how flexible these objects are and how you can have different types of properties. In this particular case, how you can have properties that are objects. The outfit has a color, size, cost, and whether they're new or second-hand. One option would be to add each one of them here, for example, outfit color, and then give this a value of blue, and do the same thing for the other ones, outfit, size. But as you can probably imagine, there's a better way of doing it, which is to treat the outfit as an object as well, because the outfit feels like a self-contained entity. So it makes sense to represent it as an object. So we can have a property called outfit. And that property on its own can be an object. And this object, if we press enter, we can start adding more properties to this new object. So this is going to be color, size, let's say that medium, cost, and lastly, whether it is new or secondhand. So let's call this is new, true. If we save now and show in the console, you're going to see that this outfit object was added. And if I expand this, you're going to see that we have all the properties as before. And then we can also expand on the outfit property as well and see what the outfit's properties are, the color, the cost, etc. If we want to access the outfit and any of its properties, we follow the same logic. Let's go and access the color of the outfit. I'm going to do player.outfit and then .color. Basically, it's like you go one level at a time. So firstly, we are in the player and we want to access the outfit. And now that we are in the outfit, we want to access the outfit's color. A quick challenge for you. Modify the size of the outfit of the player. Pause the video and have a go. Great, well, let's see how we can modify this property. Player, we want to go to the outfit first. And then now that we are in the outfit, we want to go to the size. And now that we are in the size, we can change it. We can change it to small. And if we now show the player again, we should see that the new size of the outfit is small. As you can see, objects are a really useful construct that allow you to represent an entity in a more compact and precise way than by just using a lot of separate variables. This allows you to keep your code more organized and more readable. And it's definitely going to save you a lot of time when you're building apps or websites or games. Thank you for watching. I will see you in the next lesson. While traveling in space, your team published their first game. It was a total success. So much so that security your team member, who's not known to be very talkative, pitched an idea for a virtual pet game. Since there's still time until the next solar system, why not give it a go? In a virtual pet game, we're going to have stats for the player. That's going to include health and fun, so 2 numbers. And you can see how we would want to use an object to represent our player. Besides those numbers, the player is going to be carrying out certain actions. There's going to be an action to eat an apple, which will increase the player's health. They can also eat candy, which will decrease its health, but also increase their fun. And they're going to be able to play, which is going to increase their fun. In this lesson, you're going to see that we can use an object to do all of this. In particular, for the actions, we're going to be using methods. Methods are simply object properties that are functions that can be executed. In this lesson, we're going to be looking at how to declare methods, how to execute them, and also we're going to look into what's called the context in JavaScript, in particular the this keyword, a really important concept in this programming language. We are going to start this lesson with a challenge. Create an object to represent the player, which needs to have health and fun, 2 properties. Pause the video, have a go, and come back for the solution. Well, let's go and create our player. Let player equal, I'm going to declare an object by using the curly brackets. I'm going to press enter to add some space for my properties. Health, let's give this a number of 100 to start with. And fun, we're going to give it 0 to start with. And add the semicolon at the end of that declaration. We're going to start with the first of these methods, which we're going to call eatApple. When eating an apple, let's say that the health is going to increase by 10. This number is completely arbitrary. You can change it to whatever you prefer. So let's go here, add a comma, because we're going to add another property, and we're going to call this eatApple. Colon, just like you do with any property, and here's what's different. This is going to be a function. There's not going to be any parameters to our function, and we're going to add the body of our function, curly brackets again. And inside of our function, all we're going to do for now is just show something in the console, just to be sure that this can be executed. So we've declared our method, and just like with a function, if we're not executing it just yet, this is the same as having a cooking recipe. You don't get a cake if you have a recipe on how to make a cake. You actually have to execute the recipe to create your cake. So we're going to go and execute this method. And to do that, we're going to type the name of the player, of the variable, and then we're going to use a dot to access the property. The property we want is eatApple. And we're going to execute it just like we do with any function, like so. As you can see, that shows me eatApple as expected. So we're able to execute our method. Now we want to access the health from inside of this method. How can we do that? What happens if I simply type health? Let's see. Can I access the health in this manner? Error, right? Because health as a variable is not defined. Health is a property of player. And if we are in a method of player, the way to access health is by using the this keyword. This.health. This gives you access to what's called the context. And the context inside of a method is the object that owns that method. So inside of eatApple, if we type this and then dot, that gives us access to all of these properties. Let's save and see if this works. Great, so that's how we can access the health. And we don't just want to access the health, we actually want to increase the health. We're going to increase it by 10. The new value of health, this.health, will be equal to the old value of health plus 10, which is the same as saying this.health plus equal 10. This is increasing this value in 10. And we are going to execute that, and then we're going to show the player in the console. And if we execute that, you can see that health has been increased to 110. And then this is what the new values are. Health 110. And you can also see how eatApple is shown here as a method. And this is just to indicate that this is a function. all of these things that are shown here are just part of default JavaScript function objects. You don't need to worry about any of that stuff. Basically, what's important is that it is showing eatApple and it is showing it as a function. Now let's go and create the next one of the methods, which is to eat candy. Eat candy will also have an impact on health, but in this case it will be negative. So this.health minus equal, let's say 5. So this means that we're going to reduce it in 5. And the fun is going to increase in, let's say, 5 as well. A challenge for you is to create the last one of the methods. Pause the video, have a go, and come back for the solution. Alright, so let's go and add the last one of the methods, which is called play. This is going to be a function as well. And all this is going to do is increase the fun, and we're going to increase it in, let's say, 10. So now we have 3 methods here. And we can execute them in as many times as we want and in any order that we want. Play, or you can have eat candy. And all of them are going to have an impact in the stats of our virtual pet. Now, eat candy and eat apple are both methods where you're eating something. So it would be a good idea to maybe combine them in a single eat method and then pass on the food. And then depending on the food, we could check what's going to happen. So I'm going to add that method here before I delete the other two. It's going to be called eat. It's going to be a function and it will have a parameter. Let's call this parameter food. So if food is equal to apple, then we're going to make certain changes, which we already have here. This change here. But if the food is a candy, then we are going to do something different. We're going to decrease the health and increase the fun. So let's go and try this out. Let's go and do player.eat and pass on an apple as a parameter. And you can see that, and let's show the player again after that. And you can see that the health was increased in this way. Since we have this eat method, I'm going to delete eat candy and eat apple. It's good not to repeat ourselves, so we can have just one eat method. That's definitely better. And that is everything for this lesson. So we've got a simple object here which has methods. And all of a sudden, your objects have become much more powerful. Because now they don't only store information, but they can actually now have different behaviors. And when you're working in JavaScript, you're going to see that objects and objects with methods are all over the place. It is one of the core building blocks of this programming language. Thank you for watching. I will see you in the next lesson.